Good morning, everyone. It's a pleasure to be here, to be invited here to talk of space once again. And in fact, I should start with what the topic is: applications of space technology beyond satellites. And one of the panelists really asked me, and very rightly, what is there beyond satellites? What do the organizers want to talk about? Well, I have made my assessment of what it could possibly be, and it is the most important domain of space, and that is the space applications. You know, the most glamorous part of space, which we all know of, is rockets, satellites, and here is a man who has been getting launches done from Sriharikota for a long time. We welcome you, sir. And but beyond that, today when we talk of the space economy and what it can do for all of us, and all of you today, early morning when you have started from home, you've used space. You've checked the weather, you've used space. You've used Google, you've used space. If you've transferred money or paid something, you've used space. Space is now become part of our life and all, and this is what is it we will be talking of beyond satellites, what is there. I should start with, this is a figure of what is the space, global space economy. It is approximately 360 billion, which it was about a few years back. Now the figures go to 450 and 600. But giving you a breakdown of this, out of 360 billion, 19 billion was in satellites and 6.28 billion was in launch vehicles. Just a minuscule 6 to 7%. Much larger share is of satellite services, satellite applications, and they are increasing by the day. Be it outcomes of Earth observation, be it outcomes of satellite communication, where we have the lead representatives in India, and that is Eutelsat OneWeb. You know, that itself is a very interesting story for India. We have hop, step and jumped to the low Earth observation satellite constellations in India, where we have a large ownership thanks to Bharti Airtel. What is the story about? Low Earth was not used for communication for a long time. What was used was the geosynchronous orbit, meaning at 36,000 kilometers. The advantage of that is that if you have a satellite at that height, you can cover the whole globe with one or maybe three satellites. And that satellite is more or less constantly seeing a place on Earth. So there's less technology difficulties in getting communication from them. But the disadvantage was, if you have used satellite phones, there was a latency. When you spoke, there was a latency which had issues. Disruption in technology came when low Earth observation constellations got started being made. Basically what it is, they brought it down to below 2000, around 500 to 600 kilometers, where there is better speed, there is no latency, very low latency. And in this, one of the companies which was first there was OneWeb. It originated as a company owned by UK, and today we are proud that we have ownership for it with Bharti Airtel. More of it we'll ask one of the speakers to talk about it. This is in satellite communication, and from satellite communication emanate multiple applications. I'll talk of it later. Then is the PNT, and PNT, as they call it, is position, navigation and timing. What it gives you is, today Google, logistic movement, defense, weapons to missiles, their guidance, everything is being done by PNT. And every day the usages are increasing. Today your Ola and Uber, if it locates you at a point and a delivery to you is done by, as soon as you order it, by Blinkit or whatever, they are using position, location information, and that in somehow is connected to PNT in space. In India, we are proud again that we have a Navik system of 7 satellites, which is there in space, where it is providing information. There was the issue of ground receivers for it for some time, and there was one of the frequencies which India was not getting, but that has now been resolved, and more of Navik will now be used. In fact, the law says that it has to be taken into all mobile phones, and the new generation phones already have something for it. But I see in another few years, you will not be using GPS, but would be using Navik. That is our aspiration. And the third and the most important dimension of space applications has been Earth observation. And in Earth observation, I am not going to talk what all the usages are. They start from agriculture, which traditionally was supported by ISRO when they started the initial activity and the initial satellites, to today. Today is a very important day for India. We have today reached again into the clubs of those nations which have a capability of space docking. I hope you heard the news about it. ISRO today has been successful in carrying out space docking, that is making two objects, two satellites meet and connect with each other precisely. And it is really beyond rocket science. Rocket science was about sending a rocket up in space, and now the new thing is in space, autonomously controlled. This is all, nobody is controlling it, it is autonomous. These two satellites went away from each other for about 2 kilometers. Slowly they met together. There were issues for some time, but yesterday this has been successfully done. What one advantage India has had in the last 60 years is we have had an organization called ISRO. And the government did put faith in them, put their money there. And what it delivered was in very little money. We are in the high, in technology we always say we are behind in AI, we are behind in this, there is a technology gap for the West and whatever. But in space, we are equal to the best. In fact, when we landed Chandrayaan 3 on the South Pole, we were the first country to do it. And this space docking will beyond, as you know, the Indian program will take it to, by next year or next to next year, we'll have a human being, first Gaganyaan mission getting successful, then to having a space station, and then beyond by 2040, definitely we'll have a human being on moon. Now in applications is where we are every day. The use cases are increasing multifold. ISPA carried out a study along with NESCOM and Deloitte to identify what all use cases of space there could be, and we identified 240 used cases. Now I'll stop here and hand over to the panelists, all of whom are experts in providing usage of Earth observation in India. And I would request each panelist to introduce himself, tell us about his company, what is he providing today, his company providing today, and what do they see the future as. We'll start from one end, and I would request you to introduce yourself before.
I don't know. Am I audible? So I'll ditch this. Yeah. So okay. So thank you, sir. It's always a pleasure to be, in talking with you. I think that's the country, the people of the country leading we as this very small. You want me to speak on that? Yeah. Is it? Yeah. Right. Thank you. So that's the new. This is the new India, right? The leaders of India, ISRO, or say Indian Defense, Modi, right? They are leading us and showing directions. Say a small company like ours, we are a very small company. I'll talk through. We are getting the directions. We are getting I'll say pat on the back that we are doing right, and when we are doing right, and of course been said, okay, something is not right. So that's also outrightly been told. Sorry. So this is New India, I'll say, and I'm proud to be here. I'll say representing my company, which is the culmination of what India, ISRO, and some of the strategic leaders have been doing for years. I represent a company called Suhora Technologies, 6.5 years old company. We basically do downstream applications. We don't do rocket. We don't do sensors. That's colleagues to do. What I do when the data comes back to Earth, what happens with the data is our domain. So that's the downstream application. So sir rightly said, you have seen Google Maps today, right? So that's the the downstream applications talking here. Even a little more, Zomato, because it's raining, might want to charge a little more because there's raining and some of the roads are getting flooded, right? How they get to know this? Because of these Earth observation applications. They can not only see where are the areas, how much is the rain is going on. They also know what are the roads submerged in water, flood. And of course, some of the places they might say no because it's not reachable. Now, if you think this through in a little larger context, say Bihar, West Bengal, nowadays even Rajasthan getting flooded, right? So you want to use this technology in a time-sensitive manner, near real-time manner, and put it across in front of the decision makers, who needs to send those, say, whatever the aids they need to send to the people, aids, medicines, etc., and make use of it in a real-time manner and give it to, say, NDRF, National Disaster Recovery Forces, right? So now we are talking here. That's what we do. We as a company bringing the near real-time multi-sensor data. That's one side. Anyone and everyone who wants to access satellite data, irrespective of weather, irrespective of the situations, irrespective of the use cases, we have a platform which gives you 250 plus sensors availability in your farm. You can task literally right now over Anda's hotel at least 10 times a day, at least, considering the weather. And you can use it for whatever reason you want. So you want to see the amount of cars parked in front of it, amount of people, or maybe what is the infrastructure in Anda's hotel itself, right? That's one. Second, we do defense. So that's very close to SAT's domain. So we do defense in a way that our borders are being monitored, surveillanced with using our our capabilities of not only bringing sensors, optimizing the collections over vast borders that we have and the complexities daily multiple times, but also extracting informations a government, Ministry of Defense, or say our national security agencies would like to have to secure our sovereignty. They need to know certain things. Those are been given to the users in a very, very time-sensitive manner. I'll say near real-time manner. So that's second. Third, of course, as a company, we do disaster monitoring. We do monitor disasters as when they appear and deliver to the right kind of stakeholders, be it central government, NDMA, or state government, SDMA, or whosoever wants to use it, on the golden time period, so they can use it for decision making, right? And also, this is have a multitude of applications, right? If you need to pay out for, say, I'll just give an example. Last year, there was a hailstorm in UP, and CM said, okay, I need to pay out to those farmers today itself. How you do? There's no way you can go and visit those and meet those farmers and come up with the actual scientific grade information scale, how much is lost, and for individual farmers level. This is what we can do actually. In few hours we can collect not only entire state, we can also analyze what is the damage has been happened because of that 2 hours of hailstorm. So these are the three applications areas, or rather these are the three domains we as a company been doing. We are 6.5 years old company, serving many major, I'll say, strategic customers, both on the central level, also state levels, civilian and defense and national security level applications. And let other panels touch upon the other applications. Yeah.
Thank you, Krishanu. Jyoti, he has a unique company he heads because they are trying to do something different in space. They are combining two sensors which as a norm have not been combined. I'll leave it to him to tell you what is so unique about his company, what are they aspiring to do, and where have they reached.
Thank you, sir, for the kind introduction, and thank you, the organizers, for giving us the opportunity to talk about the technology which we are developing. So, as sir said, I represent a company called Galaxeye Space. First, little bit about me. When I started my career, there were a lot of constraints when it came to the technology as well as usage. When there was nothing, nobody could fathom out what we are doing. To tell even to our parents what we are doing, it was very difficult, right? Thanks to Google, people started understanding what is Earth observation, what is geospatial technology and all these things. When we started, the computing power of a desktop was not so enormous that we can do efficient computing using images. So we had to use supercomputers, I was in CDAC at that time, to analyze the images. And again, the government also has a lot of constraints that the industry could not come in other than application development. Correct me if I am going wrong, sir. But over a period of time, with the advancement of technology and government policy, a lot of radical changes happened, and companies like us, Galaxeye Space, as a star, we came into existence and we started developing satellites, right? Now, where we are unique, as sir rightly said, we have two sensors on the same satellite, that is SAR and EO. This is first time, of course this is unique, but this also increases the risk for us that we need to be successful, otherwise this technology we will take more time to develop and prove. So why we have thought about it? As Krishanu said, we can look into an area 10 times a day if weather permits. So there, with the Earth observation, the common multispectral data, you have that challenge. That if it is cloudy, if it is foggy, then you have a challenge of interpreting the images because you can't see the Earth properly. Whereas, if you look at SAR, which can do 24/7 imaging, whether it is night, day, foggy, cloudy, anything, you can do the imaging. But interpreting a SAR image is very difficult. I think sir can vouch that much more than me. So we thought that if we take an image, a sensor which has both capturing the data with same look angle at same time, we can fuse the data. So what happens, we will get the best of both the worlds. From the satellite image, which is easier to image, when I say satellite image, optical or multispectral image, where I can get all the interpretation easily done, because since childhood we are very, used to seeing an image or a photograph and analyzing it. So we can get that, and the cloudy or night part we can overcome using the SAR. We still can do it, but the challenge here is the SAR has a different look angle, optical has a different look angle, they are captured at different times. So the fusion can still happen, but it is not sync fused. We are calling the data which we will provide is sync fused. That means it is synced with the time and the look angle. So that's one. That is why I had asked sir the question, what is going to be covered as part of this discussion? Because I come from space also, right? But thankfully we do something which is a product for different verticals. Like for defense, we are working to develop some product where we can do a fusion, cloud removal, fusion of the image and cloud removal, or object identification, delineation of changes. We are also have a product for aquaculture, which is for shrimp farming. See, what we thought that everybody is now working on agriculture. So if everybody is working on agriculture, so where are we different? So we thought of picking up something where not many players are there. So we developed a product for shrimp farming. Now again, coming back to the sensors, when we thought of developing a sensor for the satellite, where both these are available, both the sensors are available, we realized that we can't take a risk of going directly to the satellite. So we developed something, a similar kind of sensor on drones. So we have a drone-based SAR and multispectral sensor, which in India it is available commercially for first time. As of now, there are no other manufacturers who has SAR sensor or both the sensors on the same platform. And we are now doing couple of proof of concept projects with government. Right. So that's how we are trying to establish our credibility and data image quality for particular use cases, and creating a downstream applications also, which is the main focus of the topic. I think now I will give it over to Krishanu, who can talk more, and then the questions I can take later.
Yeah, so Atanu comes from Altz Technologies, and he's an expert, and he's been so long in the geospatial world. But today I want him to specifically tell us how is he using space in what he is providing to the industry, and what are the opportunities in the future for that. And before that, of course, what his company has been doing in India for a long time, and how is your complete market developing over the years.
Thank you, sir. First of all, thanks to the organizer. There's uniqueness today again. Today is National Startup Day. And I think you're a startup, he's a startup, I am a startup, and he's also part of startup. So I think the ecosystem itself says that what's growing in this market segment, right? There's a huge policy shift that has happened from the government standpoint. Now you see every single tender or every single policy change has a geospatial component or a space tech as part of the overall portfolio. I think that's a huge shift. As Jyoti said, previously we had to convince people. Today, there's a pull factor that is coming up. And I think the policy shift has brought in a lot of changes, plus opening up to the private sector. I mean, ISRO has been in the forefront of this. They have taken that initiative. Now, since there is a lot of private people are coming in, there's a lot of data that is getting created from space, right? And when you're talking about data, it's not about just optical data, which means that you're looking from a camera and picking up the images, but there are other sensors, like the SAR sensors are coming in. There is a lot of, multispectral things are coming in. There's a hyperspectral coming in. We are also talking about signal intelligence, which means that you're talking about telephones being tracked or satellite communication being tracked, right? Which is critical not just from a standpoint of defense, but there is a civilian use cases also that, and I'll come to one by one of them. Now, I stay in Gurgaon, so we all know about the Gurgaon floodings, right? I don't get to know where the floods are, where the inundation is, and I got stuck for 4 hours, right? So can I do something with the space technology, right? Yes, you can. Today we are in Delhi NCR. Every second day there is a new GRAP rule which comes in. I don't know whether I should take my car out or whether I should not take my car out. I think I am trying to make your life simpler, right? And the whole technology, where it started making sense of where the problem is, and am I able to address that, is going to change the way we see the adoption of the technology. And I think space, going beyond space, is something that am I able to solve the real world problem using the sense of where. So that means a lot of data is getting generated from satellites, right? When I talk about data in various forms, right? That information, when it comes down to application, it is made intelligent, right? So it becomes an information which is more intelligent. But can I have an actionable insights? Can I know objective that tomorrow, if I say a type, if there is a rainfall in Gurgaon of so much for 1 hour, where are the places which will get inundated? It may say that whole of Gurgaon will get inundated, but that's okay. But at least I know. So what we are trying to take this information is that we are pinpointing to what is relevant to that particular user, right? Similarly, when we talk about space, we are not looking space just from the top standpoint, but we are looking at maritime. Can we find out something which is below water also? Or can I go underground? So while space is just looking over the ground, different other technologies look beyond the ground. It's underground also, which is very important from a standpoint of how we look at and how we behave and mimic the real world to take a actionable insight. That's the whole idea behind when we are looking at the space application. So what we do as an organization is that whether you give us a data, whether it is a signal intelligence data, whether you give us a SAR data, an optical data, we make sense of their data by combining those data sets, right? Give you a small example. Maritime I'm taking is because that's where you have a lot of signal intelligence comes in. There are a lot of, I don't know whether you are aware, there are a lot of dark vessels which goes out. They are commercial, they can be trawlers, they can be some other activities. But and there is something called AIS within a ship or any kind of a vehicle, any kind of a vessel that is there in the sea. They switch it off, but they still have a communication that is happening, right? The communication or signal intelligence satellites pick up that communication and locates you where it could be in probable distance of 5 nautical miles. That is enough for us to understand how the ship is going. And these can be commercial ships also, right? These commercial ships go dark, they dump somewhere in the sea, middle of the sea, which can be, pollutants, which is not good for our country things like that. So we can start picking up those information. So these are small things, but what I think is that what does the future looks like? We are talking about computing at the edge. When we say making sense of every information, today we are not going to have resources which are going to take a huge amount of time of 1 hour, 2 hours to make an intelligent decision. We are talking about taking decision on the edge. So there are a lot of satellites which are inbuilt with the application which clearly identifies the change and says that this is the change that has happened. I think people are moving towards the edge. The other thing that is coming up with ChatGPT and all that is that today, if you type something on a ChatGPT, it tells you how to program. But I am going to put this thing that we are trying to evolve is that, again, same. Where is a graph for, initiated, right? I'll be able to say if that is Gurgaon, whether it is Delhi or if it is Noida, so that I'm able to take my car to that particular region. So what we want to bring down is to level where you write a random query and do not need a specialized training to adopt this technology. That's my 2 cents on this.
Thank you for that. And before I hand over to the next speaker, just to put you into context, there is a term called marine domain awareness. That is knowing what is all happening in the sea. And there is an international law by which, what he was talking of, AIS systems. Every ship is supposed to have a system where it sends out a signal which is received through a satellite, and the data is there that you know what is moving, say, in the Bay of Bengal, in the Arabian Sea, in the Indian Ocean. So now ships have been categorized as to a white shipping, which is a ship which follows the law and which gives it signals. It is supposed to be timed after a certain time, and you know where it is going, and you track it. Like on a highway, it is on the sea lanes, you can make it out. But then our dark hulls, what he talks of is somebody who is not following the rule, who switches it off because maybe he wants to do smuggling or want to put some illegal something, or maybe for fishing in somebody else's EEZ and all. And then there is a third word called grey hull, which I wanted to tell you is, grey hull is military ships, ships of the navies of different countries, because they have an option to give the AI signal or not give it. So we call them the grey hulls. All these 3 by any nation would be required that they are known. And previously, if somebody switched off, like he said, the signal you would go blind and would not know it. But now, if there is any kind of communication from there is a fingerprint. They can make out that this ship 20 days back was in the Gulf of Oman, and now it is in the Strait of Malacca, and this signal has come from there, and they can go backwards and trace the ship. This is what is happening in the sea, where the numbers are much lesser. But as you are aware, our government of India is very soon going to make tolls very easy. And what is the trial going on is that every vehicle which goes on the expressway is traced by a satellite, and the money they have to pay for moving a distance is paid up from the space, and nobody has to stop at their tolls and get delayed for a long time. Of course, there's a extra fuel which is there when your engine is there and stopping and all. They are having trials at two places in India, and maybe in a year you will be all connected by space, while you pay your toll, and you will not maybe be able to avoid it also. But it gives a lot of information which can be positively used for traffic management, for many other things and all. Now I'll hand over to Yetender. Yetender, tell us about your company. Tell us what you are providing today. What are the what in the future you think you will be providing?
Namaskar sir, आप सभी लोगों को. Namaskar to all of you. So first of all, I want to extend my heartfelt gratitude to IMI for organizing such an event where I can see all my seniors in the panelist, and it's really honor to share this stage with these esteemed panelists who come with exceptional experience and expertise. So I'm Yetender Singh Negi, and I represent a company, space-based intelligence service provider company called SATPALDA. So we are partnered with Maxar, we are partnered with Black Sky, we are partnered with Excel Space and Synspective. So while each of us, providing satellite imageries is what we do within our capabilities. So my main concern is that what we have achieved beyond just providing satellite images. So I'll start, I'll give you an example that while exceptionally we are competitors, we all are competitors in business, but we unite seamlessly when it comes to serving our nation needs. So a very good example of Wayanad situation where multiple landslides took place. So due to torrential rainfall, whole area from Mundakai to Churalmal, whole area was devastated, buildings were demolished. So one of the survey department of Kerala, even though ISRO, they acquired SAR imagery, but one of the survey department from the Kerala, they required EO imagery so that they can do the damage assessment. So we started tasking the satellites. So from 31st of July, we took multiple shots, but due to it was very cloudy, so we were not able to make it. But somehow on 4th of August, we were able to acquire EO imagery of that particular area. But it was a bit cloudy. So we gave this imagery to survey department of the Kerala, and what they did is that they superimposed their Khasra map, their revenue map. They took that revenue map from the state revenue department. Then they superimposed our satellite imagery with their Khasra map. After superimposing it, they detected that how many buildings in that particular Khasra number has been demolished. So once they know Khasra number and that building which was demolished, they know that this Khasra number has been allotted to whom, to XYZ. Now they not only know that how many buildings were demolished, how many Khasra numbers was demolished, they now know that how many peoples are missing over that particular area. So we provided this data to survey department of one of the survey department of the Kerala, but not only us. In fact, Planet, one of the whose reseller is like Suhora, they also provided Planet imagery, 3.7 meter imagery for the validation of the readings that they have done. So this exemplifies that how we prioritize our fundamental duties, our competitive interest. So that's it. This is something which I think it's beyond application of space technology beyond the satellites we do. Thank you, sir.
Okay, I will now put this question to all the panelists, and you could. What we are looking at is, today, like we are sitting here, and 3 of our members are in applications. What are the opportunities in Earth observation? What would you say is the market today internationally, in India, and what is it likely to grow? And what would be the sectors where you see there is a maximum opportunity in this for use cases? I'm asking you these are what experts are trying to find out, and you would yourself be very keen to know about it. But just to throw a light on it on a larger picture of what it is.
Right. So I'm definitely not an expert to answer these, though. But I'll try to figure out from my point of view, right? So in terms of the satellite data and its I'll say penetrations, right? So it's a heavily defense-oriented market. Defense leads the way. I'll say if I get to assess this, around 70% is defense only, and that's quite large, because, we, as India, as a country, I mean, I'm talking with India right at this moment. So it's has its own complexity in terms of securing the borders, that is there as well. So, and we don't shy away, spending on those areas. And I'll not put a number, but it's in hundreds of millions for sure. And if it is then that 30% that what I'm talking, the civilian applications, of course, those are, I will say the adaptation of satellite data is not more than 15 to 20% that it could be actually, and that lies also the opportunity, and that itself will nothing less than around say 100 millions, at least 100 million US dollars, and as I say, around 15 to 20% is the is the penetration now, and that means there's 80% is there to be tapped, and that's where the I'll say adaptations generations has to be made by the industry like us to create a customer aware that the satellite data or Earth observations can very well be part of their whatever the projects, the problem statement they are handling with. And I think, as you said, what are the future perspective, right? So the government, the role of government and pushing geospatial as its core technology, as Atanu said, so that shows the way, that's 80%. I think next 10 odd years, it's a sufficient enough time if it be aggressive towards that to tap that market. So India definitely will nothing less than, I'll say 1 billion worth of market can be in next 10 years. So that's the India, what I can refer, but global, again, I'm not the expert, maybe, he has some more intel to share. Please.
Thanks, Krishanu. I think, as Krishanu highlighted, India is growing at much faster pace as compared to across the other geographies or other countries. If you look at currently Indian market is around 0.3 billion, and market for across the globe is around 5 billion. Whereas if we look at 2033 or 34, India will be around 1.5 billion and market will be around 9.5 billion. So if you look at CAGR, the CAGR across the globe will be somewhere around 17, whereas for India it will be around 16. So if you look at the growth which is happening in India is phenomenal. Yes, as we were discussing, these are the potential numbers, right? In actual, we face still a lot of, roadblocks or decision making sometimes take time, but this is what the area is, and this is the potential addressable market, I will say.
Okay. Atanu, you can start with the larger picture of geospatial and then come to it.
Okay. What the numbers that has been thrown around is about the EO community, right? So I'll say about the overall geospatial ecosystem, which includes your whole data collection that is happening from various field visit, drones, space and all that. We'll talk about data creation, authoring, and we'll also talk about application. This market runs in hundreds of $1 billion globally. In India, we are looking at an overall market of $3.2 billion, right? That's the number that I have for the current 5 years. In next 10 years, it will go further. As Jyoti said, we are on the higher side in terms of CAGR. And if I remember correctly, the geospatial analytics market will grow more than 20% in India. And I think that's critical is because today there is a huge amount of data that has been collected, right? And I think that's the opportunity that we have as a nation, right? Because that will make sure the data you have collected is applied on ground to make efficient operations, whether it is utilities, whether it is defense, whether it is infrastructure projects, whether it is water resources, and I think these are very important factors, and I'll come down to those use cases also. So from a number standpoint, we are at a place where, we are just rising on the hockey stick, right? As I call it as the hockey stick effect. We are rising on the hockey stick effect. A lot of private partnerships are coming up. InSpace is doing a lot of private partnership. ISPA is spearheading a lot of association and collaborations along with us. Having said that, some of the, as you asked, what are the verticals that you see which will be a focus? Defense and intelligence globally will remain number one usage for this particular technology, because every single country would like to defend themselves before they grow, right? Now, what are the opportunities that are there from an Indian perspective? And I think apart from defense and intelligence, I see a lot of usability in climate change, environment, and the whole, yeah, exactly. So what we see that is a big market space that we are looking at to coming. And when I say climate change, I'm talking about afforestation, deforestation, all kinds of flora, fauna, and understanding how it is affecting our daily life. One is that. Second, water is going to be another subject of big investment and focus that we'll be using satellite technology. I'm not so sure if you're aware, river linking project has come out clearly by Prime Minister, right? Now, river linking project has got many aspects, right? There has been a huge debate that is going on from an environmental standpoint and from a feasibility standpoint. Why? Is because today we have regions which are dry, and there are rivers which are flowing water and going to the sea, and we are not utilizing that. That's the argument that government has. The environmentalists have that it has not been successful globally anywhere, right? They have tried to do it in a couple of European countries, and it has not been successful. China has done a lot of dams project, right? They have success stories there. So I think water is going to, because that's the crux at the end of the day where your whole irrigation, farming, agriculture is dependent. So that's the other sector that I'm looking from a civilian's perspective. Third, urban infrastructure, right? These are three things that I can think immediately come in sense. The other thing is that a lot of, when I talk about urban infrastructure, we are just not looking at smart cities as a project, but we are looking at bee towns and going to Amrut, which is a government initiative to look at sustainable cities. We are not looking at smart cities, but we are looking at sustainable cities. So anything that is sustainable will come into picture. So these are the 3-4 areas that we see that growth will be higher than rest of the places. Agriculture definitely has always been there, will be there, but the advantage of using this technology will come in terms of efficient handling the whole agriculture practice. And I'll say, when I say agriculture practice, insurance companies, agri-insurance companies are going to do that well, right? Compensations will get driven more in a better way and in an efficient way. So it's not just the agriculture, but it is beyond the agriculture where we make it a sustainable agriculture. That's my take on it.
Thank you. Yetender, over to you.
Okay, so verticals like disaster and town country planning, who generally go for the master plan, and missions like smart cities, Swamitra, and solar projects. I think they contribute a lot to Indian geospatial market. Yes. So I'm not the expert, but yeah, coming to the numbers or the round figures, around 370 crores was it was in the 2023, and compound annual growth rate may go to 20% till 2028. So I think there is a lot of opportunity for us to add value to the nation's project and schemes. Yeah.
Jyoti, you wanted to add something?
So I didn't touch much about the applications. As Krishanu rightly said, currently defense is the biggest market. So when we were talking once with Maxar, we understood that 80% of the revenue comes from the defense, right? But what I see is over a period of time, in next 5 years, you will see other sectors like agriculture, like disaster, like climate will grow. Recently, when I was talking with somebody, one of the interesting use cases which is coming up now, a very small use case which we didn't think much, is elephant-human conflict at the jungle borders, right? That's where the satellite images are getting used now. So these are the applications which will grow over a period of time. Certainly defense will still be a critical market, But certainly other markets will grow and defense will shrink a bit. That's what is my particular assessment. 80% to 70% or 70, 60% will come over the next 5 to 10 years. That's how I look at it.
Just to add one more.
Amen.
Yeah, just to add one more. Defense is definitely in US. NGIA does the most of the buying of the capacity of all the satellites, right? Whether it is Maxar, whether it is anybody, Hawkeye, Black Sky, and things like that. In fact, to that extent, Pixel has also, which is an Indian space-based company, has tied up for the capacity with NGIA. NGIA is nothing but it's National Geospatial Intelligence Agency in US, which actually captures all the satellite-based information, right? So the understanding is 80% will remain defense. Yes, defense will be the biggest user, but I think, I think the similar capacity needs to be developed in our case also as a nation, so that, there is enough for everybody.
So I think, it's not about, that ratio actually. This is actually making that pie bigger. This pie needs to get bigger, right? So I think that's going to happen in next few years.
So before we end, I would like one of you, whoever volunteers, to tell us, like, one of the concerns here in Delhi for us has been the pollution. And crop burning was an area which was very critical. Has space helped really? And how has it done it? Have you become a problem for the farmers, or you've been able to really cooperate to do something in it? How have you done it? Which are the agencies which have employed you, and what have been the outcomes of it?
So I'm direct beneficiary of this. I'll the stakeholder for this question actually. So we deliver to Haryana government intelligence about each day what are the farmers, which are the farmers burnt their farm each day, every single day. For of course this is done during those crop burning seasons. Penalizing or not, that's the government to decide. But that's the technology I'm talking. Now we can define, or we know because we do have access to certain I'll say Earth observations, thanks to again Earth observations, and the capabilities of processing that data in a time-sensitive manner. The data comes to a server, and we can process it within few hours. And while I'm saying processing means processing and delivered, that information is delivered to the users in few hours every single day. So that is something it's being done right now while we speak. And it is already so the movement was for us. It was always a occurrence based to acreage based. That what has happened recently. So it used to be how many occurrence of fire in so and so locations. Of course, the dependency of certain I'll say satellites. Because of its resolutions of it, we used to miss a lot of, I'll say, occurrence. With some higher resolution, higher frequency satellites, we can identify each farm level. That's one. Second, again, because of this sheer repeativity and resolutions that is increasing day by day, we know even if in one farm, it is the whole farm has been, got, burnt, or it's a portion of it. So acreage is also very crucial part of it. So that is being done right now. We are delivering to some of the industry, some of the organizations like Haryana government, and we are trying to exercise for the other areas where this is one of the use. So on the penalizing side, I guess the government is really thinking to subsidize who is not burning, and that's right now is the talk of the town. So whoever is using a better, wiser way to I'll say dispose of their crop residues are getting, I'll say, subsidized. So that is something happening, sir. Yeah.
So it's more like giving benefits rather than penalizing, which will work. Right?
And we are being penalized for being there. I'm sorry, but I'm just said the sentiment of it. But I'll take it up because this is, when we talk about space-based technology, it is more to do with, post the event has occurred, right, in case of farm bombing, right? We have to look at, and since the number of satellites is going on, And if we can have edge computing, we know when in the night the farm burning has started, you should start act on that. But that's going to stop the pollution. Otherwise, we are not going to stop the pollution. Yeah. We are going to give benefit who's not doing it, but not penalizing those who are not doing good. So I think there is enough scope, but then we'll have to look at it.
So just to add, I think when we have to predict, now we have a lot of historical data over the years, which we know who are the habitual culprits.
Yes.
Right. So we can do a prediction model and know and keep an eye on those particular farms where these are most likely to happen. So in that way, penalizing becomes, or rather I will not say penalizing, restricting them becomes much more easier. We can keep an eye whether they are going to do that again or not.
Then at least we'll start breathing.
Exactly.
You know, we can go on and on to the applications which are there. But before I end, one last question I want to have is, today there is a big competitor to space in many of these activities and applications we are talking of, and that is drone. Is there a fair share of the market between what drones can provide and space can provide, or they are exclusive to each other? How do you see this? Because drones definitely have developed a lot in the last few years. So anyone who would.
So, of course, I don't see this is actually going against each other. I definitely believe from my core of my heart this complements each other for sure. Say, think for a moment, you want to do something in a, say, Delhi scale. It's something 1,000 square kilometer size-wise, right? You want to do something that requires a high frequency monitoring, say, for example. It cannot be drone. But you want to create a AI or ML model to train your system where the pipeline for the data remains satellite and the training comes from drone. I'm just thinking of out of the mind. So those kind of scenarios are happening right now. Larger area being monitored using satellite, and smaller pockets for the quantification of something that's done in using drones. That gives a bigger or better rather I'll say solutions to sustain. So I think it complements each other for sure. Yeah.
You wanted to say something on this?
Just to add to another scenario, if you look at Dubai government, they do a base mapping after every 5 years using satellite images. But every year they keep an eye where the new settlement or new development has happened. At those areas, they either use aerial or drone depending on the size of the area. They do and update their base maps, right? So as Krishanu said, it's not conflicting, it is complementary. So you need not fly the entire Dubai to create a new base map again. You go and identify the changes and fly accordingly, whether aerial or drone, and update your base map every year.
So to add on this, sorry, it's going, I think, a little longer. But, this is not happening in Dubai only. This is happening right now in Gurgaon. Okay. I'll tell you how. So Gurgaon, the GMD, right? GMD does these change detections every single day, if they need to. But in a normal situation, it's, every 7 days. So the changes where they identify use a little coarser resolutions images, so they get a blip, right? And that blip goes back to certain whoever has the mobile applications. Now they are coming up with it. It's not even that person. It goes the drone. That coordinate is sent to the drone to go and verify, take the pictures in near real-time manners. It goes in a pipeline. Understand this whatever is going on the ground. This is happening right now in Gurgaon. I think that speaks its own volume, right? So.
This was a very important aspect I asked you, is because the policymakers always ask this question: why should we use space if we have drones, or the vice versa? It is very, very important for you, because these two technologies, I personally feel, and I strongly feel, they complement each other. Certain accuracies may be what can be given to you by drone may not be available from space, but what the larger view space gives cannot be given to you. How it has to be utilized and all, we have to educate the users much more to get the maximum out of it.
And comes into
Yeah.
play. And of course, we as I think we all startups here, we have to come up with those ideas and persistently push it to the requirement. So they start at least adopting, say, doing some pilot studies. I think we have to do that. So that's how we create that
Yeah.
pie bigger, I guess.
So I will give the last time a mic to all of you for just a minute to summarize what you do. But before that, I would just for interestingly, Khasra, we are talking of Khasra number. Where have Khasras originated from? Anybody can make a wild guess in the room. It is from the Mughal period, Todarmal. And we have not changed it. Our land mapping still continues from the period of the Mughals. And from, of course, that great man Todarmal, who first time did this revenue mapping for agriculture.
So at least something is not British.
Yeah.
After it goes to Mughal.
I'll now, from one end, I'll ask you to quickly, in 1.5 minutes, summarize, say anything you have a thought in the end, and then we'll close it from one end. We'll start from Yetender and then Atanu.
Okay, so at last, I'll just share some challenges that we were facing till 2023. Many satellites or the sensor that were deployed, it was into, they were orbiting polar-wise. That means they were logged in a local time frame. That means that you were only able to acquire imagery from 10:30 a.m. to 1:30 p.m. But now, many operators, many OEM, they're coming up with satellites who are deploying their satellites in mid-inclination orbit. That is from 63.4 degree north to 63.5 degrees south. So, that's where maximum world's population exists. So, now they're coming with such sensors and they are deploying the satellites in mid-inclination orbit. So now we are able to monitor any given area from dawn to dusk. So I think this is something, which the challenge that we have covered. Yeah.
Thank you, Yetender. Thank you for that. Atanu?
Thank you. Satellite-based will always remain. You cannot do away with it. You may have complementing technologies coming in. You may have drone, you may have cameras, you may fly at any orbit at a level which is up to 500 meters, kilometers and stuff like that, but satellites will remain. One, there is viability. Second, there is commercial angle that will come into picture, right? So these are the two aspects of time, cost and quality. So if you're ready to compromise any one of those, then satellite will go up. Otherwise, it will always remain. Today we are talking about 15 centimeter accuracy satellite, right? When you fly a drone, depending on what you are trying to do, you're still compromising on maybe the accuracy, depending on the kind of sensors that you have. So I'm not getting into that debate. It's completely. As far as application is concerned, I think we are just at the start of it. We are at the surface of it. If we go deeper and deeper, we will make more sense out of it. That's a huge opportunity for Indian-based industries or startups to come out with that and look at the global market. I mean, we have seen many success stories, not just from India market, but taking this technology to global. And I think that's an opportunity that we look at as an industry, we look at as a technology practice. And again, we have been saying this, we want to be a number one company in AI, which we still want to achieve that. And Geospatial is one place where we are talking about AI to the greatest extent possible, because we are talking about recognizing identities on images. Right?
Thank you. Thank you, Atanu.
Just to add what Atanu said, that there are two which are complementing. One is satellite, other is drone. I will like to add two more in near future. One is apps, other is geostationary. Geostationary, because then I will get more synoptic view, more regional view. I can do a first level assessment, then come down to satellite. For continuous monitoring, HAPS, which is high altitude pseudo satellite, new concept. We are working with NAL to develop sensor for them, and then drone. And then comes land cameras and everything. Other thing, which is very interesting, is newer applications which are coming in. One of the new applications which is taking a lot of interest from everybody is the carbon credit. That's where Earth observation and geospatial technology is coming in a big way. So we need to keep looking at these newer application areas as well as newer technologies to capture the data. That's my take.
Thank you. Definitely.
So I think we are actually having this renaissance in space technologies right now, happening right now in our back, on your back in India. So what happened 20 years back on the IT industry that India took world for its in its course. So that's happening again for the space tech. Please subscribe to India's story, India's journey. This is the journey of its own, and we're going to change the world. And we're going to do the same that happened 20 years back again. In this decade. So I think that's my take.
Thank you.
Thank you.
So I would end with a dream which I always talk of, and this is a study done in America around 2019-20. What would be there in space in 2060? And they came out with 7 to 8 likely contingencies, depending on how science develops, how many other things happen. I'm talking to you about the best case. What would happen in 2060? There would be thousands of human beings who would be working in the cislunar space. What I mean is multiple space stations where manufacturing would be done. Mining would stop on Mother Earth. All mining would be done from asteroids. If we get it right, all power will be delivered by beams. No fossil fuel will be burned on the blue planet. And travel to space would become easier than travel in air. And who knows, your children and maybe you get married in somewhere in space. I leave you with that thought, and thank you.